Hello, my name is Maximilian Schrapel, and I'm presenting to you our project MultiWave, a mobile function generator for haptic feedback in virtual reality. There are already amazing products on the market like the Tesla suit with 80 electric muscle stimulation electrodes, and also the Takt suit with vibratory feedback. But our question was, how can we improve these products and what can we do to make effects more realistic? It turns out that we have two methods. First, we can use more actuators. And second, it was of particular interest to use different signal parameters on the actuators. But what are the signal parameters? So first, the function that corresponds to the signal shape and sensation on the body. We can use square waves, DC outputs or sine waves. We can also imagine any kind of function that comes to our mind. Secondly, the amplitude can be changed, which corresponds to the tangible strength of the sensation. Third, the frequency, which determines how often a signal is repeated per second. Last but not least, the phase between the output signals of two or several actuators is of particular interest to enable sensations such as water waves. The problem is, if we multiplex a signal, we can't really synchronize the outputs, and this is why we need independent output channels, but with microcontrollers our possibilities are limited. But why is the phase so interesting? For this purpose, consider modern haptic output devices such as voice coils or EMS electrodes that require high precision signals. We also know from related work that we can achieve sensations like a moving actuator on the skin that feels like a moving bug, for example. This answers the question why we should use FPGAs to generate signals. First of all, we can generate high precision signals and synchronize all output channels. Furthermore, we need minimal space on the PCB and can control an almost unlimited number of actuators independently or dependent. For our prototype via UART, all channels can be controlled with a simple protocol to ensure easy integration into projects. For signal generation, each PWM generator requests a new value at each time step via an update logic to prevent concurrent reading. Any function with a resolution of 10 bits can be stored in the memories, and we control over 300 user-defined custom functions. We also offer basic functions such as rectangle, DC, sawtooth, triangle and sine waves. Each individual time step value is then amplified by the formula. We have eliminated critical paths through dividers by using magic numbers that transform a constant division into a shift operation. All basic parameters such as number of ports or baud rate for connection can be changed via top-level parameters in our implementation. To achieve a mobile system, we have developed two expansion boards for the DE development board family. On the bottom, the battery board that can supply up to 12 amperes and operate 80 actuators at full intensity over 1 hour. And on the top, the control panel with Wi-Fi and Bluetooth connection, as well as Arduino header for other projects. We support 80 actuators via the GPIO headers. In order to test effects, we have developed a software and API in Python that can be used to control actuators even without knowing our UART protocol. We have also built a test grid with 80 actuators that can be attached to various surfaces with Velcro tape. Here on a chair, we can, for instance, enjoy a massage generated by FPGAs. Then we created our final prototype based on a warning vest for mobile use. It can be adapted to the size of the user and worn under a jacket. The prototype is clipped to the trousers pocket. As virtual reality headset, we use the new Occulus Quest, as it can be worn mobile and has inside-out tracking for the controllers. We call our virtual environment Sensation Island with the intention to escape everywhere from everyday's life. We have placed objects like waterfalls or bombs in this environment to give the user the feeling of being inside of this world. Every time the user touches an object, the vibration motors on the vest are controlled. Here we use a capsule model for the user's character that provides a good representation of the human's body. More realistic models would require more computing power, which is not available on the Oculus Quest. Although we have focused our demo on virtual realities, for the future we also see applications such as blind navigation. So it's really fun to run in such an environment, but to show you what's like, let me show you our demo.